Well, hello there, you rascally little environmental science students. We are going to wrap up our Unit 11 lecture series with this fantastic lecture number 4 here, right? And primarily what we're going to focus in on is solutions to our major air pollution problems and what those solutions look like. The reading that accompanies this particular lecture is pages 617 through 624 from chapter 19. The weather's getting nice. I recommend sitting outside and reading if you can. All right. So we're going to differentiate, excuse me, a couple terms really fast. That would be point source pollution and non-point source pollution. All right. So controlling and mitigating air pollution, it's probably easier when all the pollution comes from one location, and probably a little bit more difficult controlling pollutants when it comes from lots of little sources, what we might call diffuse pollution. And so when we refer to the term point source pollution, we are talking about a kind of a single large contributor to our air pollutants. And the best way to think about that is if, let's say, down the road there's a power plant that burns coal, right? That would be a single large contributor to air pollution. And that would be a point source pollutant, all right? Same thing, by the way, applies to water pollution. At least point source and non-point source pollution does not just apply to air pollutants. It applies to any source type of pollution. But that being said, if we have a single large contributor, we call that a point source pollution. Lots of smaller contributors, that would be non-point source pollution. Right? So you can think of, the carbon dioxide and sulfur emissions, et cetera, that come from a power plant that burns coal as a point source. But the much smaller but cumulative emissions of a ton of little vehicles would kind of be more of a non-point source. And you guys kind of see where, in a sense, we have essentially just a couple of innovations to control pollutants at a power plant, whereas each individual vehicle operated by another individual person is responsible for those non-point sources. So it's a little bit more difficult maybe to control pollutants from vehicles than it is from a single source like power plants. All right? So you guys just make sure you know what we're talking about when we use those two terms right there. So how do we go about reducing air pollution? All right? So we talked earlier lectures about how important that is, right? Hundreds of thousands of deaths per year are linked directly to lung issues from air pollutants. Right? So basically, the innovations come down to three main categories. We have what are called regulatory practices. So we put in place laws, for example, and then to accomplish the goals of those laws. So we put in devices to still basically operate with the same behavior, but reduce the harmful emissions from it. So we might put in what are called electrostatic precipitators or scrubbers in our large power plants, or what are called catalytic converters on our vehicles. And we will go through each of those three things here shortly. Right? But those are regulatory practices. Now, what we could also do is the basic conservation. So just like back in our energy unit when we talked about one of the solutions is looking for alternative forms, one is making the current forms of energy cleaner, right? But the easiest and cheapest thing to do is just to use less, right? So if we're using our automobiles less and using less power, right? If we use less, we're going to pollute less. That makes it a much easier problem to tackle that way. And of course, we have alternatives. So if instead of burning coal at a power plant, they burn natural gas, that right there takes care of a lot of the pollutants that they worry about. Now, it doesn't deal so much with the carbon dioxide, et cetera, but it does reduce the sulfur and other particulate matter emissions because natural gas is so much cleaner. All right? So these are the three ways by which we can go about reducing air pollution, right? And we are currently, of course, operating with using all three of these. All right. We're going to focus mostly on regulatory practices, just simply because we've sort of already covered conservation and alternatives in previous units. All right. So the Clean Air Act is one of the big environmental legislative pieces that was put in place originally in the 1970s. So originally implemented in 1970, updated in 1977, and then again in 1990. All right. So what the Clean Air Act has done is it's tackled the kind of the 6 major air pollutants: carbon monoxide, nitrogen dioxide, sulfur dioxide, ozone, particulate matter, and lead. And then with the updates, they've added about 150 or more other hazardous air pollutants. Right? And so what it does is it gives a legal binding so that vehicles, for example, have to pass emission standards. And power plants and metal smelting places, they're limited on the amounts of sulfur dioxide or nitrogen oxides or carbon monoxide they are allowed to emit. Okay, the Clean Air Act gives legal binding. So companies that don't abide by Clean Air Act legislation can get fined or even end up serving jail time if the problem is ongoing, right? Now, one thing to notice is that carbon dioxide is not on that list. We are still not treating carbon dioxide as if it were a pollutant. Now, going way back in time, back to 1970, for example, carbon dioxide was not a big concern, right? Because it's a natural part of our atmosphere. It's part of cellular respiration and photosynthesis and so on. We're still not operating under the idea that we have to limit carbon dioxide pollution. Now, you all know, of course, that we do, and hopefully in the near future we're going to turn the tide and tackle that issue. But carbon dioxide is not included in the Clean Air Act legislation. All right, now, here's something that's pretty, it's interesting, and it's evidence that we can do some good. Right? So, for example, between 1980 and 2015, over this timeline, what's been really cool, gross domestic product is increased, right? At the same time, our population's gone up, vehicle miles traveled have increased, our energy consumption has increased, but because of the Clean Air Act, right, our aggregate emissions have decreased by 65%. Right? This shows that well-implemented, science-informed legislation can lead to considerable reductions in environmental impacts. All right, so again, how do we go about doing this? Well, several ways, right? So some regulatory practices, again, there's been some conservation and efficiency things tackled. We've implemented some alternative fuel types, right? Coal is phasing over to natural gas at a pretty alarming rate. Different problem for a different day. But let's say we're not changing. Let's say where you have a coal-fired power plant or metal smelting or some other industrial process, right? So they're still burning coal or whatever fuel they're burning, right? But they engineer ways to reduce the pollutants by doing the same thing. And one of those things is what's called an electrostatic precipitator, right? And what it does is it's an electrically charged rod, essentially, that goes into the smokestacks of the exhaust, right? And by it being electrostatically charged, it attracts particulate matter, right? Basically causes that particulate matter to stick to that rod, right? And then it is able to settle out into the floor of that collector as opposed to going out into the air in the form of smoke. Now, how well do electrostatic precipitators work? Well, if we look at this picture of exhaust without an electrostatic precipitator, and we go to that same location, and we basically just turn the power on, that is what the reduction in particulate matter looks like. So what you're seeing, right, in smoke essentially is actual solid particles, right, that are small enough to basically become buoyant with air currents. Okay, without electrostatic precipitators, we're putting tons and tons of particulate matter into the atmosphere. With precipitators, we can get rid of the vast majority of that particulate matter. Right? Now, it is important to keep in mind what you're not seeing out of this picture is the other gases, because most gases are clear and colorless, right? We don't see them. You might smell them, but you don't see them, right? So how do we go about reducing other types of pollutants? So we got the particulate matter collected, it falls out into the collector as opposed to going out into the atmosphere. What about the sulfur oxides and et cetera? All right. So another thing that they'll put in, particularly in our coal-fired power plants, are what are called scrubbers, right? And this is, again, another mechanical device relying on chemistry. But one of the things they do is they'll spray clean water in to dissolve some of those gases, right? But then they also have a device called an entrainment separator, which basically uses some fancy chemistry to reduce like sulfur oxide emissions, right? So we got smokestacks with scrubbers, right? Reduce sulfur emissions. We've got electrostatic precipitators that can reduce particulate matter. Scrubbers also reduce particulate matter, by the way. And another thing, this is for our hydrocarbons, or what we call VOCs, right? So is it's required by law that all fueling stations, when they refill their large gas tanks, that all vapors from those large gas tanks have to be recovered. So the trucks that come and refill, as they put new fuel to fill that up, they are refilling their empty space in that truck with the vapors from that. Okay, so all of these are just legally required interventions to reduce air pollutants, right? So the College Board, those three I just talked about, by the way, are three that the College Board wants you to know about. They want you to know about vapor recovery for gasoline that helps reduce VOCs. They want you to know about scrubbers. They want you to know about electrostatic precipitators. Now, the last thing that we'll talk about, and this helps deal with the more diffuse sources from automobiles, are catalytic converters. And what a catalytic converter does, it's a mechanical device with catalysts inside of it, right, that help to reduce, they actually transform, I should say, the harmful pollutants like carbon monoxide, nitrogen oxides, and VOCs that come from normal fuel exhaust, and they convert the majority of those really harmful emissions into less harmful, right? Carbon dioxide, nitrogen and oxygen gas, and water vapor, right? And so all modern vehicles have some device on it called a catalytic converter, and what that does is the normal exhaust that comes out of your engine, right, was going to be heavy in carbon monoxide, nitrogen oxides, and hydrocarbons. These catalytic converters help to convert those into less harmful forms of those chemicals. All right. Now, so we talked about the Clean Air Act and what it's done, right? We're next going to talk about riparian ozone, which is sort of a different sort of problem. So around the same time that they implemented the Clean Air Act, they first started noticing via satellite measurements that the ozone was thinning over Antarctica in the early 1970s. Now, there are actually a lot of reasons why the thinning is happening primarily over Antarctica that I don't have time to get into now, although you could research that if you're interested. Why Antarctica when there's no air conditioners and stuff down there? It has to do with air currents and what's called polar cloud formation, but we won't get into that right now. But anyways, first started noticing that in the early 1970s. Not long afterward, Sherwood Rowland and Mario Molina, who both won Nobel Prizes, by the way, for their work, they identified the cause of that ozone thinning, which, as we know, is those CFCs that are stable in the troposphere, but not so stable up in the stratosphere as the primary culprit, right? They're breaking down ozone and preventing ozone from forming. So those are the two chemists that discovered that. And what we did in 1987, as this became more and more of a concern, is there was what's called the 1987 Montreal Protocol. College Board wants you to know this one, by the way. So it was a multinational agreement to phase out the use of ozone-destroying chlorofluorocarbons and use some other form of chemical that would essentially cause the same thing or have the same function, but not cause ozone destruction, or at least drastically reduce the likelihood of ozone destruction. All right? And the CFCs remain in the atmosphere for decades, but as of 2015, because of that Montreal Protocol, there's about a one-third recovery of the ozone, and they're expecting a full recovery by 2050. All right? So, again, this is what happens when politicians listen to science and they go and they legislate changes, right? We can, right, undo damage that we've done, right? It kind of makes you wonder, what else could we accomplish if we just stopped bickering, right? Made some legislation and put our best scientists and engineers to work. What other problem might we be able to tackle and do some good with? Adios.